Okay, today we're talking about horizontal linear transformation. So first start with the linear parent function, y equals x. And the parts that we're going to be messing with are these parts inside this b of x and plus c. So the b of x, the b, is going to cause a horizontal stretch and compression. Oops, there's no e there. And the c value is going to cause a shift to the left and right. So we always want to start off with our parent function. So the first thing we're going to do is horizontal translations. So this is when we have a function and we're taking the x value and we're either adding or subtracting something to it. And it's going to cause it to shift either right or left. Now, if we start with this, f of x equals x, and then we type in g of x, f of x plus 2. Okay, so this is c value is going to be 2. This is going to cause a translation, but instead of adding 2, you think it's going to go to the right, but it actually goes left. So it's to the left 2 units. Because what it causes it to do is it causes this action, this function, to happen earlier because we are adding 2 to it, so it's speeding this up. Our new x-intercept is 0, -2. And here, if we subtract 3, that causes a shift to the right 3 units. So to the right 3 units. And our new x-intercept is 0, 3. This is because when we subtract 3 from this function, it causes a delay in the function happening. For horizontal stretches and compressions, what we're going to do is we're going to take our value and we're going to either multiply it or divide it by a number. So in this case, we're doing g of x equals f of x, f of 2x, so our b value is 2. So for our g function, you have to view this as horizontal. So this is causing a shift this way. So this is a horizontal compression by a factor of 2. And it makes the graph steeper. So it does affect our slope. It does match our slope, similar to vertical stretches. But I'll show you in the lesson on how we're going to use something other than f of x in order to show what this horizontal compression looks like. When our b value is 1/2, this creates a horizontal stretch by a factor of 1/2, making the graph less steep. And our new slope 1/2. Because what's happening here is it is being stretched this way horizontally. And it's being stretched this way. So they act in reverse. When we're multiplying by 2, it's compressing it, it's pushing it together. And when you're multiplying by 1/2, it's stretching it out. In this last part, when we have f of bx and our b is negative, this does cause another reflection, and it's over the y-axis. So our new slope is -1. So what happens is it takes this point and reflects it over here. It takes this point and reflects it over here. And that is a look at horizontal linear transformations.